Imagine a machine so powerful it can recreate the first microseconds of the universe. So, why go through all this trouble? The goal is simple: to smash these particles together. In that tiny, fleeting moment of impact, new, often exotic particles burst into existence. It's not just about breaking things. It's about creating them from raw energy to understand the very fabric of our cosmos. Now, let's talk about what full power really means. It's not just turning a dial to 11. First, you need magnetic fields so strong they could lift an entire mountain or even a fleet of aircraft carriers. Next, you need a vacuum. Not just any vacuum, but a vacuum so empty it makes outer space look crowded. This ensures our particles don't bump into stray air molecules on their journey. Then, there's the energy of the collision itself. The energies involved are immense, but they're still far below what's needed to make a stable, world-eating black hole. In that instant, the protons themselves shatter, releasing their inner components, quarks and gluons. The famous Higgs boson, the particle that gives all other particles mass, winks into existence for a fleeting moment before decaying. Other, even more exotic particles appear and vanish in nanoseconds. Particles with strange names like charm quarks or muons. It's like searching for one specific grain of sand on all the beaches of the world. Out of this cosmic chaos, they are hoping to find answers to the biggest questions in physics. They're hunting for clues about dark matter, the mysterious substance that makes up most of the matter in the universe, but doesn't interact with light. They're searching for evidence of supersymmetry, a theory that suggests every known particle has a heavier, unseen super partner. And they're trying to piece together the history of the early universe. Each collision is a frame in the movie of creation, and we're just learning how to watch it. You might be thinking this all sounds very abstract. Quarks, bosons, cosmic racetracks. What does this have to do with our daily lives? By studying how materials react to particle beams, we can create stronger, more resilient components for everything from jet engines to computer chips. Even our understanding of climate physics and cosmic events is enhanced by the data from these experiments. And maybe a little caffeine for the scientists who stay up all night analyzing the data. Not just full power, but the very edge of what is technologically possible. At this speed, time for the protons slows photories down so much that for every 1 second we experience, they experience only a fraction of a nanosecond. This is the moment of truth. The two beams, traveling in opposite directions, are steered into a head-on collision. The resulting explosion creates conditions that haven't existed in the universe since the first trillionth of a second after the Big Bang. We are looking at the rules of phytos that govern existence itself. Every single collision whispers a secret of the universe. How matter forms, why we exist, and what lies beyond the particles we currently know. It's the ultimate exploration, a voyage to a time before time, conducted of phytos in a laboratory buried deep underground. And don't worry if a tiny black hole does pop up. So what happens after the fireworks? After a full power run, the experiment isn't over. In many ways, it's just beginning. They spend months, sometimes years, analyzing the patterns, looking for the telltale signature of a new particle or an unexpected interaction. And yes, we're doing it a little more safely each time, hopefully. From the smallest flickers of quantum energy to the grand architecture of the cosmos, it's all connected. And the only way to truly explore it is to dare to smash the building blocks of reality and learn from the sparks. If you want more futuristic, science-defining, cinematic journeys into the unknown, make sure to subscribe to Synex. We're on a mission to explore the greatest mysteries, from the tiniest particles to the vastness of space. Thanks for watching.